Datacenter FMC. This FMC has been freshly installed and all the policies settings are at their default. So let's first navigate to System and Configuration. And note that System is the gear icon in the upper right corner. So the left panel contains a number of options for configuring the FMC. We will cover some of the most commonly used items. Let's click Management Interfaces. So right initial setup of MC management interface allows basic connectivity. A common task is to add additional networking information here. So on this page, I can configure additional management interface, add DNS servers, routes, or inter-proxy information if needed. So in this lab, we will not make any changes to these settings. Click on Audit Logs in the left panel. Sending audit events to an external log server is often considered a best practice. Here I can configure the MSC to send audit events to up to 5 syslog hosts and or an HTTP log server. We have a Splunk server in our environment, so let's forward the FMC audit log here. Change send audit log to server to enable. Enter the Splunk server IP. And I will click Test Syslog Server button to test the connection. Let's click Save button in the upper right corner to save the audit log config. Let's also review email notifications. Let's click Email Notification on the left panel. The FMC can send email alerts to various events such as health, intrusion, correlation, etc. So this page configures the SMTP settings, including from email address to be used. Note that the SMTP server must be configured to allow mail relay from MSC. As with the syslog settings, there is a test button. Click this button will send a test email to an address you specify. So let's also review process settings. Click Process. So this screen is used to shut down or reboot the MMC. It can also be used to restart console, the web UI. So keep in mind that if the FMC is shut down, it will have to be manually started up again. So in the case of a physical MSC, it means someone will have to press the power button. So in some way, a virtual MSC would have to be restarted by hypervisor interface. If you do this, you will be unable to restart FMC. So in my lab, also click Database. The database is on the left panel here. Note the page allows configuring the maximum event storage right here. The upper limits for various events databases to vary from different MSC models. For larger FMSCs, it is very common to increase the event storage for databases such as connection database. Add 2 additional zeros to the number in the maximum connection events fields. So this will change the limits from 1 million to 100 million events. Click Save button. So notice that I receive an error message because MSC Virtual is not capable of storing that many connection events. So the message note that maximum event storage is supported by this MSC model is 50 million events. To see this, let's click the question button right here. And we click Page Level Help. This will open a new tab with help for this page. Click the database event limits on the help page. So this page indicates that events limits for each FMC models. Using page help level help feature is a good way to get additional information or understand more about how system operates. So this will show content sensitive information for current FMC screen. Let's close the help tab to return to the FMC configuration page. Let's configure. The 49 million connection events and click Save button. Change for the change. So for the next, before we can set up the policies, we need to create a few objects. Creating important objects earlier will make for smoother policy and rule creation later. If we know we will need to use various networks, hosts, ports, and other objects in our policies, we can create them now and save having to navigate the back and forth later, creating objects and using them in policies or connections. So we're going to create objects for internal network ranges, snorts, valuable sets, network gateways, infrastructure hosts such as log events on DNS servers. So let's add objects. From the GUI, we're going to navigate to Objects, Object Management. So there are many objects types that can be created. So when I first arrive this page, I see network objects. There are a number of default host network objects covering ranges like IFC 1918, multicast, IPv6 link local addresses. For many organizations, the existing IF 1918 range can be used to define local or internal network. So in our case, we also need to add additional network ranges. Click Add a network. We're going to add an object. First object, we're going to enter 198.18.00/15. Is that entering here? We're going to copy to network and choose network. It's going to be a lab network. Click Save. App networks created right here. Let's repeat the steps and create additional network objects for corp LAN, branch LAN. Okay. Let's create a host object for Splunk server and an internal gateway. So I should now have the following objects. I have is corporate LAN, branch LAN, Splunk server, lab network, and internet gateway. Task is to create a valuable set. In the left panel, let's click valuable site. Right here. The valuable sets are used with intrusion policy. Variables are used within a snort rules to improve efficiency and reduce false positives. The most important variable to configure is the home net. This could also be considered the protected network. This variable defaults to any means all networks. However, to improve the efficiency of the system, we will define home net as just we own our own internal host. The system chips with a default set. Many organizations can use this single object course or all of their intrusion policies. Larger organizations may want to create additional valuable sets for devices deployed across the multiple network topologies. We'll create a lab-specific valuable set and use that with our intrusion policy. Click Add Valuable Set. The name here we use is lab snort variables, and let's add scroll down, and scroll down I'll find is the home net right here, and click the pencil, and we will add the lab networks and the system object group for all the IFC 1918 addresses to home net. So adding all internal IP addresses to home net is a secure firewall best practice. From available network on the left, and we're gonna select IPv4 private, okay, our IFC 1918. Click include, and we're gonna click lab networks, include, and we'll add them to included networks. I will click save to save whole net changes. Here. We'll notice that all customizing whole net is now show in the list under customized variable right here. So let's customize the variables specified to variable set. Default variables are inherited from default set. We will click save to save my new variable set. So next task we'll do is to create the security zones. So what is security zone? A security zone is a type of interface object that is useful when I wanted to create loose or process traffic based on inbound and outbound interface. Zones can also contain interfaces from multiple devices. So if, for example, I name a zone outside, I can add interfaces from multiple firewall devices to the zone. That way, any policy I assign to a device with a zone of outside will process traffic in the same manner. As with other objects, it is handy to have zones defined before I have to use them in my device configuration. We will set up several security zones to be used by our lab firewall FTD firewalls. So the lab task here, I will get familiar with security firewalls, and I will do out zone, in zone 1, 2, 3, 4. I will follow routed mode security zones. So first task that we're gonna to create is the zones. From the web GUI, we're gonna navigate to also the objects. And object management, and from left panel we're gonna click is interfaces. Interface, we're gonna add a security zone. When creating security zone, I have two options. First, I can create zones ahead of time and then assign them to interfaces as I configured my devices. This is the method we are using. The second method is to create interfaces to all my devices but not configure a zone. After I create the interfaces, I can create the security zone in the interface page itself and or add the interfaces to an existing zone. So because we are using first method, so we do not have to specify device or interfaces for our zones, just the name and a zone type. We'll create the 5 security zones which we will use for lab firewalls. So out zone, in zone 1, in zone 2, in zone 3, in zone 4. So in the name of fields here, we're going to type out zone, and the type will be routed. Okay, and click save. Add another zone, security zone. Or repeat the steps and create the routed security zone. That will be in zone 1. In zone 2. In zone 3. Okay, 5 zone we created to finish. I should have zones appearing as showing right here. So next texture we're gonna to do is the basic access control. So the step we'll be creating a security access control policy. Because we do not have any device yet, it is too early to try and do much with this policy. However, we must have a policy to deploy when we add or manage the devices. It will be easier to create one ahead of time rather than at the time we join our first device. If you are registering server devices and to an FMC, it might be easier to create the blank or dummy access control policies that I can use temporarily as I register each device. So the only purpose of this policy is to satisfy the requirement that any FMC manager device must have an access control policy assigned. I can then add device to its actual policy later. So in managing server devices that I will create the parents and child policies. This will allow us to configure various settings in the parent and have those inherited by the child policy. It will make maintaining consistent environments much easier, especially if we have a larger number of policies. So let's first create access control parent. From the GUI, we're gonna navigate to policies. The policy here, we have the access control. Let's click new policy. The policy name will be global parent. Let's correct that. Global parent. And description, we're gonna common policy settings. So let's save the policy and let's return to access control policy management. Let's create NGFW1 policy. It's a child policy, so let's create this child policy. This is the policy that will be assigned to our first firewall device. We'll create a new policy. This will be NGFW1, and under select a base policy, we're going to pick global parent. Okay, and click save. And let's return to access control policy management. Towards the top and the left. Okay. So we finally ready to register our device to the FMC. It is this very new device you would have to start by configuring IP address for management interface. In this lab, we have a device that is already managed by another FMC, and we will repurpose it for our use here. The task one is to deregister NGFW1. So deregistering and preparing this device. Located the device, we're going to log into the first MFC, located to device and device management. Then we can find NGFW1. Click delete from the pop-up. Click yes to confirm the deletion. Now we're showing confirm the device is successfully unregistered. At this point, let's log on to the console of the NGFW1 device. At the error prompt, let's type configure firewall transparent. So this command destroys the interface configuration on the device. So otherwise, when we register this device to new FMC, they will retain most of the original interface settings. Let's type Y to confirm and press enter. So as the CLI prompt type configure firewall routed, then we're kind of enter. So configure firewall routed. Press enter. So I will again receive prompts to about interfaces. It's important to put device back into routed mode for our deployment. So next we'll prepare the device to be managed by FMC2. Let's configure manager, add FMC2, press enter. Now let's exit. Go back to FMC2 and under device management, we'll click add, select device, the host name, group is none, access control policy, remember the child policy created, performance tier, choose FTDV valuable, check malware defense, IPS, URL, so then register. Alright, here I've failed a few times to register my firewall. I would try one more time. Make sure unique NAT ID is blank. Sometimes the browser may try and fill in this field automatically. Any data here will cause device registration to fail. After a few minutes, the NGFW device should appear in the device list. It will take several minutes for process to complete. I can follow the progress by clicking the message center in the icon in the top menu bar right here. When registration is finished, the NGFW device should show in the device listing. Device is registered. Let's create a platform settings policy. This policy defines some of the configurations specific to a device. These include SSH banner, NetFlow, syslog server, time zone, performance profile. First task is to create a new platform settings policy named standard platform and add ngfw1 to the policy. We'll go to device and platform settings. Let's click new policy and we'll select TDS. Threat defense settings. The name are gonna be standard platform. And we're going to add ngfw to selected device. Save. The task 2 we'll do is to edit the platform policy. We'll configure our device to send our Splunk syslog server. On the left panel, we're going to click syslog. To set up the syslog, we need to configure some basic logging settings, define our syslog servers, then configure logging destinations. So under logging setup, and we're gonna check enable logging, and we'll click syslog server. Now let's add a syslog server. We'll check UDP and reach by device management interface. Click OK. We'll create a Splunk server here. Click OK. All right. Let's also click the logging destination tab. Let's add. In the add logging filter dialog here, we're gonna pick up this syslog filter on severity 1 alerts. Okay, click OK to save. Then we're going to view performance profile. Let's click performance profile. We'll see we can customize CPU allocation within our device depending on how it is deployed. This is less impactful for small device like the lab FTD virtual, but could be more significant for larger hardware platforms. Since our device will perform both firewall and IPS functions, we will leave it at default allocation. Then click Save. Once all deployed, we want to deploy the change. Let's click Deploy. And click Deploy All. So you can monitor deployment progress here or in Message Center.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget